these are all the things we are going to do in this video. So still stay till end of the video, because it is not only for your class 12 for competitive examinations, but also for BSc second year appearing students who are who are in your graduate level of chemistry, both of general chemistry and honors chemistry. All are going to get these kind of questions only. Okay, so very specific. Coming to the question, the first one is here: what is the resistance you have to find of 0.1 normal NaCl solution at your 298 Kelvin, that is the temperature, is given to you as your 200 ohm. Now you have to find the cell constant of the conductivity is unity. Given cell constant is unity, and you have to find the equivalent conductance. So how you are going to do the specific conductance? Okay, by formula, specific conductance K is equal to 1 by R, that is a reciprocal of the resistivity, into your cell constant. So what is given? Resistance is given to be your 200 ohm. Okay, and you have to find the equivalent conductance. Okay, now first you have to find the specific conductance, then we can go for finding the equivalent conductance. So 1 by 200 ohm into 1 centimeter inverse, so that comes to be your 5 into 10 to the power minus 3 ohm inverse Cm inverse. Okay, so your equivalent conductance, see, specific conductance is necessary to find out why we have to find the value of K. Okay, we need the value of K for finding your equivalent conductance. Okay, so for equivalent conductance, so we have to find the value of K that can be given only by your specific conductance, as it is the conductance of 1 centimeter into length of the electrode, and separated by your 1 centimeter square. So we get K. That is the constant we can get. Now equivalent conductance is lambda m is equal to K into 1000, divided by your normality. So K we find 5 into 10 to the power minus 3 into again 10 to the power 3 divided by your 0.01, which comes to be your 5 into 10 to the power 2 ohm inverse Cm inverse equivalent. Okay, so you got your equivalent conductance. Now the second question is the conductivity of the solution containing your 1 gram of anhydrous BaCl2. So the conductivity you have to find, and it is given 1 gram. Okay, BaCl2 is given to you, that is your 2 centimeters. So conductivity 0.0058 ohm inverse. The molar conductivity and equivalent conductivity for the solution you have to find out. Okay, conductivity is given, the K, value of K is given, and you have to find molar conductivity and equivalent conductivity. Now atomic weight, so molecular mass, atomic weight of Ba and Cl is given. So molecular mass we have to find of molecular weight of your BaCl2. So it comes to be your 137 plus 2 into 35.7. That comes to be your 208. Now 208 as 1 gram of BaCl2 is present in 200 centimeter cube of solution. 1 gram of BaCl2 is present in your 200 cm centimeter cube per solution. Okay, so that means what happens to the molar conductivity? So molar concentration C is your 1 by 208 into 1 by 200 into 1000 ml minus 1. This is your molar concentration. This is 1 by molarity, and this is 1 centimeter in length divided by your, this is your volume of water solution, and this is molarity of the solution. Okay, that is 1000 ml. Now what you are going to get is 0.0240 mole liter inverse. So molar concentration is this. Molar concentration is this one. of BaCl2, that is 101 by 108, because 1 gram now. So the weight, what is molar concentration? How to find molar concentration? Molar concentration we find by weight in grams divided by your molecular weight. Okay, in weight in grams into 1000 divided by your molecular weight. Now see, weight in grams is how much? This is 1 gram, and this is your molecular weight, that is 208 into, that is how much of anhydrous this is being used. It is 200 centimeter cube is for 1 gram. So for molecular concentration will be 1000 ml divided by your 200. So you are going to get your, this is your molar concentration. Now molar conductivity you have to find. Molar conductivity, how do you find molecular conductivity? Lambda m is equal to K into 1000 divided by your concentration C. So K is given to you 0.0058 into 1000 divided by your 0.0240. So this comes to be your 241.67 ohm inverse Cm inverse mole inverse. If you calculate this by using a scientific calculator, you're going to get this one. Now in case of equivalent weight of BaCl2, that means your how many chlorine ions, or you're talking about only barium ion or only chlorine ion. So in case of BaCl2, equivalent weight is nothing but your molecular weight divided by your BaCl2. That means how many ions it is separating. So it is, chlorine is how much out here? It is 2 chlorine. So 2. Okay, so BaCl2 divided by 2, that is your 208, that is your molecular weight, divided by 2, that is 104, becomes your equivalent weight. Now concentration, therefore concentration of solution in gram equivalent weight per liter. Okay, concentration of equivalent weight, that is 1 by, again 104 into same procedure like 1 by 200 into your 1000, that comes to be 0.480. Therefore conductivity K into 1000 divided by concentration of equivalent weight, that comes to be your 120.83 ohm inverse. You just put the solution value, put the value of K, put the value of C concentration, that is 0.480. So you are going to get this value. Now we'll go to the other question. So the next question is, the resistance of the conductivity cell when filled with 0.2 molar KCl solution and your 164 ohm at 298 Kelvin. However, when filled with your 0.05 molar AgNO3 solution, its resistance is found to be your 78.5 ohm. If specific conductivity of 0.02 molar KCl solution is given to you, you have to find the conductivity of your is 0.05 molar of AgNO3 and your molar conductivity of AgNO3. So what you have to do is that, see here two solution is being filled up simultaneously in the conductivity cell. If it is KCl solution, then your resistance is 164 ohm is given to you, and if it is then filled with your only silver nitrate solution, then it comes to be your 78.5 ohm that is given, and the specific conductance of KCl is given to you, and you have to find the molar conductivity of 0.05 molar in AgNO3. Okay, so how will you find that? See, you have to find first what the calculation of your cell constant. Now specific conductivity 0.02 molar KCl solution is given to you, that is your 2.768 into 10 to the power minus 3 ohm inverse Cm inverse. Specific conductivity of KCl solution, 0.2 KCl solution is given to you. So what is given first we are going to write. Then comes your resistance is given. That is your 64 ohm. Now, your specific conductivity, what is the formula of specific conductivity? Specific conductivity, it is 1 by R into your cell constant, that is L by A. Cell constant is length divided by area of cross section. So, cell constant. Now, 1 by R, that is 1 by 1 by R. Okay, so we don't know what is the cell constant. We have to find what is cell constant. But specific conductivity is given to you. For this, it is your 2.768 into 10 to the power minus 3. And your resistance is also given. If you go take R to this left hand side, it becomes your 164 is given to you. That is comes to your cell constant. Okay, so what is your cell constant? Cell constant value comes to be your 0.4539 cm inverse. Okay, so this comes to be, so now conductivity is equal to what? 1 by resistance. It is conductivity is inversely proportional to 1 by resistance. So conductivity is 1 by resistance into your cell constant. It is proportional, so removing the proportional sign, if you put equality, that time you have to multiply with something that is called your cell constant. So conductivity of what we are finding now, AgNO3. Conductivity of AgNO3, cell constant, it is 1 by 78.5 is resistance is given to you, and cell constant we have got just right now, that is your 0.4539. Now this comes to be your 0.00578 ohm inverse Cm inverse. Okay, so we got number 1, that is we have to find the conductance. Next we have to find your molecular conductance. So how to find molecular conductance? Molecular conductance number 2, that is your calculation lambda m of 0.05 molar of AgNO3. Put the formula, this is nothing but your 1000 into K divided by molarity. 1000. What is K? That is your conductivity. Conductivity is now 0.0058. We found out the conductivity. Okay, divided by your molar. What? How much molar? 0.05 molar given to you. Now this comes to be your 115.6 ohm inverse Cm square mole inverse. This 0.5 normal solution of your salt placed between two platinum electrodes, that is 3 centimeter apart, that means length is given, and the area of cross section is given to you 6 square kilometer, has a resistance of 0.25 ohm. Resistance is also given to you. Calculate the equivalent conductivity of the solution. You have to find equivalent conductivity. Okay, so the first step is length is given, how much? That is your 3 centimeter. Area of cross section is given to your 6 centimeter square centimeter, and resistance is given to your 25 ohms. So conductance is nothing but 1 by R, 1 by resistance into your cell constant. That comes to be or 1 by 25 into what is cell constant? Cell constant is length divided by area of cross section. So length is 3 and area of cross section is 6. Okay, 3 ones are 3 2s are 6. So it comes to be your 0.02 ohm inverse Cm inverse. This comes your conductance. Okay, or you can say specific conductance. Okay, K we found out. Now second step, what we have to find? You have to find now what is your equivalent conductance. Equivalent conductance. So what is equivalent conductance? It is equivalent conductance is your K into 1000 divided by concentration at equivalent. Okay, so this is your equivalent conductance, concentration at equivalent. K Okay, how much normal? 0.5 normal solution is given to you. So this is your 0.5. Here 1000. And what is K? K we found out, specific conductance we have found out, that is 0.02. Okay, put this value here, then find, and now it is 40 ohm inverse Cm square equivalent minus 1. So this is, now we found out this is your equivalent conductance. So this way you are going to find all the numericals, and next we are going to discuss Cole-Rash's law. So again, with Cole-Rash's law, what we are going to do, it's numericals we are going to do and its applications. So now the topic comes is your Cole-Rash's law. What we discussed is that when there is a strong electrolyte, we use Debye-Huckel's Onsager equation, okay, that we got for strong electrolyte. But this one is for weak electrolyte at infinite dilution. Weak electrolyte, okay. What happens for weak electrolyte? So weak electrolyte at infinite dilution. Okay, so here is that according to Cole-Rash's law, the molar conductance of an electrolyte at infinite dilution is the sum of the molar conductance of the ions produced by the electrolyte at infinite dilution. That means, in other words, it is said the sum of the molar conductance, sum of your molar conductance of cations and your anions at infinite dilution. These things you can write in your copy. Dilution is called your molar conductance of infinite dilution. So when suppose there is a beaker, at infinite, here it is, you have CH3COOH. Okay, so what it means, it has which kind of ions does it have? It has positive and the negative ions, right, in the solution. That is your CH3COO minus, this is the negative anion, and this is the H plus. So this is the two ions present in this mixture. So at infinite dilution, it is very weak electrolyte. It is weak electrolyte, it does not completely dissociate. So in case when there is a completely you add water to it, infinite dilution is taking place. That times what will be its molar conductance? Molar conductance mu of this solution at infinite dilution will be, this is the number of protons into the conductance of the proton at infinite dilution plus your anions, sum of the anions at your infinite dilution. Okay, so this where n plus and your n minus are your cations and anions respectively. Okay, so this is the formula of finding, the two molar conductance of electrolyte at infinite dilution. The multiplication of the number of the ions with molar conductivity at particular ion is called your molar ionic conductance of a particular ion. So what is your, now there is another word or topic that is called your molar ionic conductance. The multiplication of the number of the ions with molar conductance. Or suppose there is a, you can say, suppose there is a molecule like CH3COO minus ions, okay, and this H plus. Okay, so it is the, suppose you're talking only about your concentration of CH3COO minus, that times we talk about only one concentration, only we are talking with respect to this anions. That time the multiplication, that means with molar concentration of the particular ion, that means of this ion at infinity, is called your molar ionic conductance of that particular ion. That means if we talk about, we are talking about this one, how many molecules of this is there present in the electrolyte, and multiplying that with the molar conductance of one anion, that will give you the molar ionic conductance of that particular ion. Only you're talking about here one, so it can be a H plus also, it can be of this one also. Okay, so beside being helpful in calculation of the degree of dissociation of the weak electrolyte, this law also helps us in calculation of the molar conductance at infinite dilution form, weak electrolyte. Suppose we have, okay, so now the conductance of this one, okay, so if you are taking of CH3COOH, mu at infinity of this electrolyte, that is CH3COOH, according to this one, what it will be? It will be mu of infinity, that is your CH3COO minus and plus conductance of your H plus. Okay, so these equation can be obtained by the knowledge of the conductance at infinite dilution for strong electrolyte. See, now this is a weak electrolyte, but here we are assuming that it is a strong electrolyte. So if we assume that it is a strong electrolyte, it will, that means the molar conductance will be what? It will be the sum of the molar conductance of the anions and the plus the sum of conductance of the cations. Okay, so of infinity of this CH3COOH, what will be the equation of this? It will be CH3COOH. Okay, in the reaction medium it becomes CH3COO minus Na plus your HCl. Okay, if this one reacts with the sodium chloride, okay, if it is there in the reaction medium, that times it forms this and this. Now what we can say, the molar conductance of COO minus Na plus, what will it be? We are talking about this one now. It will be your mu of your CH3COO minus, okay, at infinite dilution plus mu of infinite dilution of sodium plus. I'm just talking about this one. And now we will talk about HCl. Mu of infinite dilution about your acid. What it will be? It will be mu infinity of H plus mu not Cl minus. This is number 2. This is number 3. And here another electrolyte, what it is there? It is NaCl. So this is again molar conductance of infinite dilution of NaCl forms your molar conductance infinite dilution of Na plus molar conductance at infinite dilution of Cl minus. Now the above equation 1, this one can be obtained by the adding first and second and then subtracting number 3. So we get what? So by adding 1 and 2 and subtracting equation 3, adding 2 and 3 and subtracting this from number 4, we get mu infinity of CH3COOH is nothing but your mu naught COO plus mu infinity of HCl minus mu naught infinity of NaCl. Okay, for the weak electrolyte. For calculating the degree of dissociation is equal to mu naught C divided by mu naught at infinity. This is your degree of dissociation, where your alpha is the degree of your dissociation and mu naught is your molar conductance at any concentration. Okay, and mu naught, this one is your molar conductance at infinite dilution. Okay, so the conductance of an electrolyte increases with the increase in the temperature of the solution. This is due to the increase in your temperature of the solution. If you increase, that time what happens is that the mobility or the kinetic energy of the solution increases, so the ions resulting into the movement of ions. So as if you increase the temperature increases, mobility increases, and in turn what happens is that in turn your you can say conductance increases. So we have discussed on the factors that the conductance depends also on the nature of the solution. We have discussed about the two types, that is your strong electrolyte and your weak electrolyte. Now we are going to solve some sums based on these topics we have discussed, and more we will be doing in my further videos. I'll be doing some more sums for you. Okay, so the question is, for strong electrolyte, the value of the molar conductivity at infinite dilution. So molar conductivity at infinite dilution, it has been given to you. For strong electrolyte, what is the conductivity? For BaCl2, it is this, this, and this. Now you have to find the molar conductivity of BaOH whole twice. Okay, so we will start with the solution. BaCl2 plus twice NaOH. You have to you the if you see the reaction, what will be the equation? You have to divide. If you have to decide it by yourself by seeing the reagent given to you. So it is BaCl2 and twice NaOH gives your BaOH whole twice plus twice NaCl. Okay, so this is the balance equation also. So now what it will be, we know by your Kohlrash's law, the molar conductivity of your BaOH whole twice, okay, it is nothing, this one will be nothing but sum of this minus this one, okay, as the equation implies. Okay, that is your BaCl2 at infinite dilution plus this one, molar conductivity of NaOH, okay, minus your 2 times the molar conductivity of your NaCl. 2, it is because 2, it is number of moles. So here we are only one conductance of each molecule is given to you. So what will it be? Put the value. It is 280 into 10 to the power minus 4 plus 2 into 248. Okay, so here also it will be 2 because twice NaOH is 248 into 10 to the power minus 4. Then you have minus 2 into 126.5 into 10 to the power minus 4. So you calculate this, multiply these things and add these. So what it will be? It will be 523.0 into your 10 to the power minus 4 sm square mole inverse. Okay, so this is, with this way you have to solve the sums and all. So this is the question based on your Kohlrash's law. So if the molar conductivity is at infinite dilution, okay, of NaCl, HCl and CH3 is given to you. So what is given? That is your molar concentration, okay, of OOH is equal to, this is your CH3 COOH. Now similarly here, what is given? The molar conductivity at infinite dilution is given. Okay, so molar conductivity of at infinite dilution of NaCl is given to you, that is your 24. Then molar conductivity at infinite dilution of your HCl is given to your 426.1. okay, and molar conductivity at infinite dilution of your CH3COO Na is given to your how much? That is your 91.0. Ohm inverse Cm square mole inverse. Same here, same here. So this is whatever is given to you. Now solution. Okay, we know that what happens is that, what is Kohlrash's law? Kohlrash's law states that the amount of the ions dissociated, that the molar conductance at infinite dilution will be equal to your n, that is your number of the ions into the molar concentration of the this ion, that is anion, plus your cation one. So for all the cases, we can you can separate it as anion cation, right? You can write this one like, see, this C dot CH3COOH. okay, this can be written as lambda naught at infinity CH3COO minus plus at infinite dilution, that is your H plus. Now another one can be written as NaCl, can be written as, okay, this one lambda naught infinity of sodium plus, and your lambda naught infinity of your chlorine minus. Now this is at infinite dilution of your HCl, that comes to be your infinite dilution of H plus infinite dilution of chlorine minus ion, because they separate now when you give in the solution, they separate into ions. Okay, so this is suppose your equation 1. equation number 2, and equation number 3. So what we have to find, we have to respectively what will be there, what will be that of acetic acid. You have to find what will be the molar concentration of acetic acid. You have to find, and it is given. This sodium salt of acetic acid is given, HCl is given, NaCl is given. Now see what happens. This is the reaction. So by adding equation 2 and 3, and subtracting from equation 1, if we do, because we have to find this one, okay, we have to find this one. So if we add this and 2 and subtract from this, adding 2 and 3 and subtracting from equation 1, we get what we get: lambda naught of H plus lambda naught of Cl minus plus lambda naught of your CH3 COO minus plus lambda naught of Na plus minus lambda naught Na minus lambda naught of Cl. Okay, that comes to be your, it comes to be your 426.1 plus your 91.0 minus 126.4. So your CH3COO minus plus lambda naught of H plus is remains out here because this get cancelled now. Okay, so whatever we know is given. So this comes to be your 390.7 ohm inverse Cm square mole inverse. So the next question is, at 291 Kelvin, the molar conductivities of the infinite dilution, molar conductivities of infinite dilution of NH4, Cl, NaOH and NaCl is given to you. NH4Cl we can write as lambda naught NH4 plus and lambda naught of Cl minus is given to you 12.8. Then comes your at infinite dilution. Okay, if the molar conductivity of the century normal solution of your century normal solution, that means Cm solution is of NH4OH is given to you, that is molar conductivity is given to you, what percentage dissociation of NaOH happens at dilution. So your conductivity is given, you have to find the fraction of how much this is being dissociated. So we will use that is your degree of dissociation. Okay, so this one we can write like this: lambda naught for NaOH is, again it will be lambda naught for Na plus lambda naught of OH minus. Okay, that gives you 217.4 ohm. Okay, and lambda naught of NH4OH will be your lambda naught of NH4 plus lambda naught of Cl OH minus. Since is that this NH4 OH, that is your NH plus ion and OH minus ion, it can come from what? Lambda naught of your NH4Cl. Okay, that is total one, this NH4, because Cl ions, see here we have OH ions out here, and here in this question NaCl is given and NaOH is given. So NH4Cl is also given to you. So NH4Cl minus, if you do if you add this NaOH, okay, if you are adding NaOH, again minus you are subtracting NaCl. So if you are subtracting lambda naught at infinite dilution for NaCl, NH4 plus, okay, minus, see here this NH4 remains, this OH minus remains, and if you are subtracting this, because when you are going to write your like with the help of your Kohlrausch's law, you are going to separate the ions NH4 plus and Cl minus ion. So if you write this one together and this one together, if you add and minus this NaCl, so Na and Cl is going out. So remaining what? Remaining which ions is remaining? Only NH4 ions and your lambda naught of OH ions. So this one can be written as this equation. And so we know this value. The value comes to be your 129.8 plus your 217.4 minus your 108.9. So this gives to be your 238.3 ohm inverse Cm square. So this comes your conductivity. This becomes your conductivity at infinite dilution. So degree of dissociation. What is degree of dissociation? Dissociation means what? The degree of dissociation, how fast this has dissociated at infinite dilution. So degree of dissociation is your degree of dissociation at the concentration divided by your infinite dilution concentration. So that comes to be your 9.33, that is given molar conductivity. This is molar conductivity at the concentration C, and this is the molar conductivity at your infinite dilution. So what is the molar conductivity given? 9.33, and you have find the molar conductivity at infinite dilution, 238.3. So this gives you your 0.0392. Okay, so this gives your degree of dissociation, and the percentage of dissociation is, if you multiply this with percent, that comes your 3.92% as your percentage of dissociation. So the degree of dissociation, if you multiply with 100%, it comes your 3.92 as your degree of dissociation, percentage of dissociation. Okay, so done. This question also done. And the next question is, from the following molar conductivities given. So molar conductivity of BaOH whole twice is given, BaCl2 is given, NH4Cl is also given to you. Now you have to find for NH4OH. So lambda naught, same way, lambda naught of M of NH4OH can be written as what? So at infinite dilution, NH4 can be written as lambda naught M of your NH4 plus lambda naught of your OH minus ions. Now here it is BaOH2 and here it is BaCl2. This NH4Cl can be written as NH4, lambda naught of this, that can be written as NH4Cl, this one, because NH4Cl. Okay, Cl plus your BaOH2 lambda naught of BaOH whole twice minus you get your BaCl2. Why? Because we need NH4OH. NH4 comes from here, OH comes from BaOH, and you are subtracting BaCl2. So now here this lambda naught of NH4OH can be written like this, okay, where it is BaCl2, BaOH whole twice, this one. Now if you separate this, okay, NH4OH at infinite dilution, this becomes NH4 plus, okay, plus your lambda naught of Cl minus, because that is NH4Cl, plus it will be of lambda naught of Ba plus and lambda naught of OH minus, that is 2 into lambda naught of OH minus. Why? Because 2 molecule of OH2 na. OH2 is how much? OH is 2 molecules. Now lambda naught of minus lambda naught of your Ba plus 2 times lambda naught of Cl minus. Okay, this is the thing. So what will it be? It will be 2 into 129.8. okay, if you multiply, you have to multiply this equation by 2, this one, NH4Cl by 2, you have to multiply this 2, making it equal. Okay, so because Ba plus will get cancelled, this one will not get cancelled because here it is 2 Cl, here it is 1 Cl, so 1 Cl will be left, and ammonia also there will be only 1 left. So multiply this whole by 2 if you are doing, so 2 into this, okay, then plus your 457.6 minus your 240.6, so that your 476.6, that is lambda naught NH4 plus lambda naught of OH minus comes to be your this 2 times. Okay, if it is 2 times, so conductivity of NH4 and your OH will be your 476.6 divided by your 2, that comes here 238.6 ohm inverse Cm square mole inverse. Because NH4OH, because see here we what we did, since there was BaOH whole twice, so OH molecule it was 2 times, chlorine also BaCl2 it was 2 times, so we multiplied this NH4Cl also with 2, so we are left with 2 times of NH4OH, and this one, this NH4OH is 2 times is there, so this adding. This one is 2 times, this one is again 2 times because we multiplied it by 2. Next time we multiplied this by 2, this equation. So you are going to get 2 times of this one was this. So only one molecule if you want to find the molecular conductivity. So it becomes here divided by 2. So this is done. We have found your your infinite dilution. What is the molar conductivity of NH4OH given to us? So these are some sums we have completed. So some more examples we will do when I finish the chapter. We will again do some more numericals based on every topic. So for today I'm just ending the video, and please write in the comments which topic you want to see next, in which topic I should make the video, because I'm not understanding on which topic you really want the video is.